decisions based on logic. And now we come to the last chapter in this category. Control the flow of your code. Code, we have the loops, and here we're gonna learn two types, the for loop and the while loop. This is gonna be your introduction to automations, so they're gonna help you to make smart code instead of repeating the same code over and over. So now let's get started with the loops in Python. So now let's start with the first question. What are loops? A loop is like a tool that we use to control the flow of our code. And if you use it, you are saying like, hey, I would like to repeat this code, this thing over and over until I say stop or something happened. Maybe a condition is not fulfilled anymore. So now let's have a sketch to understand what this means. So now normally as we are coding, we write instructions one after another. And if you go and execute it, Python has to go from the top to the bottom, executing all your instructions one after another. And all your instructions will be executed from Python. So it is a straight line code. And that's great for simple stuff. But in reality, as you are coding, what could happen is that you will notice there is like a block of code that keep repeating. It will be repeated like 5, 10, or even 100 times. That means we are repeating ourselves, and this is not really good because our code can explode. Instead, what we could do, we could put our code in autopilot. So what we can do, we write this block of code only once, and then we attach it to a loop. This loop can go and execute the block of code over and over as long as the condition is true. So that you write your code only once and you repeat it as much as you need. And in Python and as well in many other programming languages, there are two main types of loops. We have the for loops and the while loops, and each type has different types and purposes. Now we're gonna deep dive into the for loops. So let's start. A for loop lets you go through a group of items one by one in order to do something for each item. So it's like you're saying, do something for each item in my list. So let's understand exactly what this means. So now we start in our code with the keyword for in order to build the loop. And once Python sees the for keyword, it's gonna go immediately behind the scenes and start building a logic, a process. So it has a start and as well a condition. And of course, this condition is not specified from us in the code. It is something that Python do once it sees a for. So the condition is gonna be always like this. Is it the last item? So it is actually asking, am I done? Is it the last item in the group of items? You'll understand exactly what I mean with this once we have an example. And as usual, the answer for each condition could be either true or false. So this is what can happen once we specify a for. Now next we have to define the loop variable. So it's like a variable that we can use to assign the current value of a sequence. You can name it whatever you want, an I, item, user, whatever. And then we use the operator in, and after that, very important, is the sequence. You define here the group of items that should be iterated. So with that, we give Python the list that we would like to iterate. And this is what we call a sequence. And now Python behind the scenes is going to take this sequence and create it out of it an object in the memory called iterator. This iterator is responsible for knowing where we are currently in the loop and what is the next item in the sequence. So it keeps tracks on what is already done and what is next. So with that, we have now the setup, the configuration of our for loop. We know how we have to iterate 3 times because we have 3 items, but still we have to tell Python what to do, which line should be repeated, right? Also, in order to do that, we have to do the double points and then go to a new line. And don't forget here the indentations. So we have to leave 4 spaces and then write the line that should be iterated. executed. Like for example, it could be print the item, and now Python knows this block of code should be repeated, and this is going to be if the condition is false. So as long as we still have items, this code should be repeated. And of course, after the execution of the print, it's going to go back to the start in order to grab the next item. And of course, if the condition is true, so we are at the end, Python going to go and end the loop, and that means we can go and execute the next instruction. So now let's see how Python going to execute this. So as usual, we start from the beginning, and now it goes to the condition. It's going to say, is it the last item? So Python going to go and ask the iterator what is next, and since we are at the beginning, it's going to go and answer, okay, the first one is 1. So the iterator going to answer Python with the value 1, and this means the condition is not fulfilled. It is not the last item. We still have values in the iterator. That's why it's going to go to the path of the false. Now we're going to go and execute our block of code, print I, and here Python assigns the value 1 to the variable I, and that's why we need the loop variable in order to assign the values that we are getting from the iterator or the sequence. And now once our code is done, it's going to go back to the start. And then what's going to happen, my friend, it's going to go and ask again, give me the next item. So now the iterator going to say, okay, we are done with the first item, then it's going to go to the second item and return 2. So Python sees, okay, we still have values, that's why we are not done yet. It's going to go back to the print, and this time I is equal to 2, and it's going to go and print it in the output. And again, it's going to go back to the start and ask the same question. Are we done? Do we have anything next? Now the iterator say, okay, we are done with the 2. Let's go to the next one, the 3. So Python going to get 3. It is not done yet. It's going to go and print it in the output, and again, go back to the start. And this time, if Python asks the iterator what is next, it's going to see, the 3 is the last item in the group. So it's going to say for Python, sorry, we don't have anything else. You have to stop. Now once Python gets the stop, it's going to say, okay, we reached the end. We have processed the last item. That's why this time the condition is fulfilled. And it's going to break the cycle and get out of the loop. So we reach the end. So as you can see, our block of code, the print I is executed 3 times. We didn't have to repeat it 3 times in our code. We just built a for loop for it, and it gets iterated. Again, it's like autopilot. All right, now let's say that we have the following example that we are printing like rounds. So we are saying round 1, and then we repeat this like 5 times. So round 1, 2, 3, 4. So now let's go and execute it. You can see we are getting the exact same stuff. So everything so far static, of course. And of course, we are repeating the same code over and over, but just the only thing that is changing is the round number. Now, of course, this is not very smart because we are repeating the same code over and over. And instead of that, we can write our code once and then put it in a loop. So we can go and get rid of everything. And then we say for I, this is our variable. And then we define the sequence like this 1, 2, 3, 4, 5. Now we go and add double points. With that, we have defined the structure of the for loop. We are saying let's iterate through this sequence. And then we hit enter. Now we have to be careful with the spaces. The indentations here should be 4 spaces, for example. And then we can go and grab our prints and put it over here. So now the print is inside the for loop. And now if you go and execute it, what's going to happen? Python will go and repeat this code 5 times. And that's because in our sequence, we have 5 values. So that means we have 5 items in our list, and Python has to go through them one by one. And with that, we are getting the output, but we are not there yet because we are printing the same code. I would like to have the value of the sequence in the output as well. Of course, the value of the sequence are always assigned to the variable. So what you can do, we can go and use our string format, and then we have to go and replace this static part with the loop variable. So we don't need it anymore, and here we have an I. So now for each round, we will get the value from our sequence. Let's go and execute it. Now you can see we are getting the exact same output. So round 1, 2, 3, 4, 5, and those values are coming actually from the sequence. So it is very simple, right? You just have to define the loop and then tell Python what to do for each iteration. Now I would like to show you something like a rule for the naming of the variable and the sequence that we usually use. So for example, we could put our sequence in a variable called items equal to this value, and then we could use this variable inside our for loop. Let's see items, but usually we can call it like this for item in items. So the variable name is singular, and the sequence going to be like plural for the same name. And it is really nice to read for item in items. And if you have like tables, you could say for table in tables, for file in files. So this is really nice. Just use the same name as a singular for the variable and plural for the sequence. And of course, we can go over here and call item, and if you go and execute it, you'll get the same results. This is really cool. You know, immediately this variable here gets its value from the items. Now, there's something important to understand about the for loop, that we have always to specify a sequence, a group of items that has a start and end. In the current example where we have the numbers 1, 2, 3, this is what we call a tuple. It is a data structure that we can learn about it later, don't worry about it, but we could use as well other sequences. Like for example, we could use a list. A list is as well a sequence. Let's have an example. So now let's check that out. If we go and remove this and have the brackets, at the start and as well at the end. So if you go and now execute it, you will get the same results. This is as well a sequence of numbers, and Python gonna treat it as a sequence. So we could use as well list in our example. And by the way, for example, let's go and remove the 5 and add a string value like hi, this. And now if you go and execute it, you will get the last one round hi. So there is no rule in the for loop that items must be either be numbers or string values. You can go and do like a mix. Okay, the next one that you could use is a string. A string value, it might looks like one value, but actually it is a sequence of letters. So each letter is actually one value. That means we can go and iterate through a string value. Let's have an example. Okay, so let's try this out. I'm gonna go and remove the whole thing over here. Let's have a value like Python. So this time we have like one string value, and we're gonna go and iterate it. Let's go and check that out. Now, as you can see, each letter gonna be like one value, and I'm gonna go and iterate through the whole string. And of course, if you have here some spaces, it's gonna be considered as well as a character. So you're gonna execute it, you'll get for the first round a space. So that you can see, our string value is not only one value, it is actually a sequence of characters that has a start and an end, and you can use it in the for loop as a sequence. Okay, moving on to the next one. What else we could use in the sequence is that we can use a built-in function called range. So let's say that you would like to iterate like 100 times. It's gonna be really annoying to make a tuple with 1, 2, 3, 4 and like define 100 values, right? Instead of that, we could use this built-in function range to generate a sequence of numbers. Now, this function we can define many things. Let's start with the one that is very common. We specify a stop. So we use the stop to tell when it must stop generating numbers. For example, if you go and say range 5, the sequence will look like this. It starts with 0, 1, 2, 3, 4. So that the total generated numbers are 5. And you can see we don't have the number 5 in the output because otherwise it's going to be 6 numbers. And this is might be confusing for many where they think if you add 5, you will see it as well in the output. Well, actually the stop will not be included because it starts from 0. So let's try this out. So now we have here again our sequence of numbers using a tuple. Now let's go get rid of this. And instead of items, we will use the function range. And we have to pass the right value. Let's pass the 5 and try this out. Now as you can see, the output, we start with around 0, 1, 2, 3, 4. So this is really nicer instead of writing like 5 numbers, right? Now if you go and say 100 and execute, it's going to be very simple. It can go and generate 100 numbers. And with that, you iterate our code 100 times. So now let's go back to our 5 example here and execute. Now let's say that this is not what exactly I need. I would like to start from the round 1, not from 0. So how we can fix this? Now we could use in the range another argument. We could use the start argument. This is optional. If you don't specify anything, it's going to be always the 0, right? But now we want our start. That's why we can go and specify the start. Like for example 1, and with that we are forcing Python to start generating from 1. So now if you execute it, we will get a sequence that starts from 1, 2, 3, 4, and then it stops. It will not include the 5 in the sequence because it doesn't include the stop. So by looking to this, the start will be always inside your sequence. but the stop will not be inside. So let's go and try this out. Now, if you go over here and say, okay, start from 1 and execute. Now in the output, it looks nicer. We are starting from the round 1 as we want. But we have the issue. We don't have any more than round 5. And in order to have it in the output, we can go and increase the stop to 6. So if you go and execute it, you'll get the round 5. And we don't have the 6, of course. Okay, now moving on to the final argument that we can pass to this function. It is the step. It is as well optional. And we use it in order to define or specify the incrementation. If you don't include it, it's going to be always the 1. So we always increment our sequence with 1. So let's say that I would like to go and generate all the even numbers between 0 and 10. And now what we can do, we can specify the step 2. So now the incremental going to be 2. Let's see what can happen. So it starts from 0. And then the next generated number, it will not be 1 because the incrementation here is not 1. It is 2. That's why the next number going to be 2. Then the next in the sequence going to be 4. Then 6 and 8. And now of course we will not have the 10 because the 10 is our stop. Now let's say that I would like to go and generate all the odd numbers between 1 and 10. So we can have the same setup, but this time we start counting from 1. So now we start from 1, then the next one, 1 plus 2 going to be 3, and then 3 plus 2 going to be 5, 7, and then 9. And with that we are generating odd numbers. So it looks nice. So let's try that out. I'm going to go and add the stop 10 over here and execute. You see we have all the numbers between 1 and 10. Then let's go and add the step 2 and execute. You will have only the odd numbers. So as you can see, the iteration is less than before because we are incrementing with 2. Now if you go and say, let's for example 4 and execute, you'll get only 3 numbers. So the step is bigger in the sequence. So far we are generating only odd numbers. Now let's say that I would like to start from 2 and end at 10, and the step should be 2. So if you go and execute it, you will get now even numbers. So it is very simple. With those 3 arguments, we can define exactly how the numbers can be generated. So this is how the range function works. So those are the famous sequences that we usually use, but you can as well use any other sequences, like for example the dictionary or maybe files. So any object in Python that is iteratable, you could use it in the for loop. Okay, so with that, we have learned how to build a loop, how to build iterations inside our code. And now, of course, always the question is, why do we need those stuff? How to use the for loop in real projects? So now in the data world, usually we have like files or tables that are in one place, and we would like to go and move all those tables from one place to another place. Now imagine that you have to write a code for each table. So if you have like 100 tables, you're going to write like the same code 100 times. Now instead of that, we can go and build a loop in order to go through all the tables one by one and start loading it to the target place. So we write the code once and we iterate through all tables. And of course, it could be files as well. You might have like 100 files and you'd like to move them from A to B. And for that, we usually build a loop. Now, if you are working with data, we might go and let's say clean up those files, those tables. And if it is always the same action that we would like to use, what we can do, we can use as well a loop. So we go again and iterate through all tables and do the same data cleansing. So with that, we are preparing the data before maybe analyzing it. Now, of course, not only tables and files, we can go and iterate through columns. So let's say that we have in our table multiple columns and they are bad quality in the values of the columns. Like for example, we have leading or trailing spaces. So of course, in Python, we could use the strip function in order to clean up the data. So now instead of applying this function for each column inside our code, you might have really big file or table with hundreds of columns. Instead, we make a loop for all columns and we iterate through all the columns of our table where we apply the strip function. So with that, instead of having hundreds of lines, you have only 2 lines of code, 1 line for the for loop and the second one for the function. So as you can see, this can be like foundations for you as you are working with data. You use it in order to load the data. We use it in order to do data preparations, data cleansing, and you can see this can be like strip function. So with that, instead of having hundreds of lines, you have only 2 lines of code, 1 line for the for loop and the second one for the function. So as you can see, this can be like foundations for you as you are working with data. You use it in order to load the data. We use it in order to do data preparations, data cleansing, and many other stuff. So the for loops are really amazing. Okay, so now I'm going to show you a few use cases where I use for loop. So we usually use it in order to do aggregations like summarizations, finding the average. So let's say that we have here scores, a list of scores, and here we have few values like 80, 50, 60, and 75. Now I would like to go and find the total of those scores. So we can go and create new variables in order to store the total score. And now in order to do the summarizations of all those values, we can go and use a loop. So we can say for, and then I need a variable. So it's going to be score in the sequence scores. And of course, don't forget the double points. And now what we're going to do, we're going to say total is equal to the current total plus the scores. So we are accumulating the values we are getting from the loop and we are storing it to the total. And of course, as we learned in the operations, we have some shortcut in order to do this. We could add the plus before the equal and then just remove this. So I am adding the scores to the total. And now we can go and print few stuff. Like for example, we can say the current total and then we say the total. And outside of the loop, I would like to see that final total. So final total and as well here, the variable total. So we can say for, and then I need a variable. So it's going to be score in the sequence scores. And of course, don't forget the double points. And now what we're going to do, we're going to say total is equal to the current total plus the scores. So we are accumulating the values we are getting from the loop. And we are storing it to the total. And of course, as we learned in the operations, we have some shortcut in order to do this. We could add the plus before the equal and then just remove this. So I am adding the scores to the total. And now we can go and print few stuff. Like for example, we can say the current total. and then we say the total. And outside of the loop, I would like to see that final total. So final total. And as well here, the variable total. So let's go and try that out. We got an issue because this is wrong. You cannot use the scores, the sequence. You have to use the variable. So the score, not the scores. We use the scores only for the iteration. So let's try again. And now, as you can see, it is working. So first we have the current total 80, then plus 50, 130, 190, and the final total is going to be 265. Right, so as you can see, we can use it in order to do some aggregations. Okay, to the next one. As we learned, we can do data cleanup, data preparations using for loop. So let's say that we have a list of files like this. So the first one can be reports.csv, and the next will be data.csv, and the third one final.txt. And let's go and add some evil white spaces on left or right in order to have some bad data quality. So now here we have two issues. We have the leading and trailing spaces, and as well, you can see we have sometimes lowercase and uppercase. Now I am a data engineer or analyst, and I would like to go and clean up the data before I do something about it. So you have to do two things. First, removing the spaces. Second, making everything either lowercase or uppercase. So depends on the rule that I follow in my projects. I have to change the cases. So in order to do that, we could go and create a for loop. We're going to say for file in files double points. Now, what are the actions? We're going to say file is equal to file. File dots, and we have now start clean up the data. So we can start with the strip function to remove the white spaces. And now in order to test it, we can go and print the results. So we're going to say processing and then the variable name file. So now let's go and test this out. So now by looking to the output, you can see we don't have any leading or trailing spaces. So everything looks fine, and with that we have cleaned up the names of our files. Now we are not done yet. We still have this lower and upper cases. Now we can go and add the second transformation, and I would like to say I'm going to go and and make everything lowercase. Now, if you check the output, it looks way nicer. Everything is lowercase and everything is following our rule. And another thing, let's say that I would like to go and get rid of the txt. Actually, we only allow CSVs. So in order to do that, we add another transformation and we say replace. Now the old value going to be .txt and the new value, our standard, is CSV. Now it is very important you don't write it capitalized because we are doing this, the replace, after we made everything lower. So it's always like this. First clean up the data and then do data transformation. Transformations where you adjust and manipulate the data. The order is very important. First clean up and then manipulate. So now if you go and execute it with that, the final is as well .csv. So this is really amazing. We write our data preparations only once and then we build a for loop in order to iterate through all our data. And this is exactly the power of the for loops. And as a data engineer, analyst, scientist, you have to do a lot of data preparations in your pipelines and you will end up using those for loops many times. So make sure to understand those concepts. They can be very important for you. And my friends, it is challenge time. So you have to go and print 7 times table from 1 to 10, but you must use a loop and it must look exactly like this output. Don't miss one character. Okay, so if you're done with this, I have for you a second challenge. You have to print the following left-aligned star pyramids. So the first line is 1 star, the second is 2, 3, and the last one should include 6 stars. And of course, my friend, you must use for loop for this. So go and solve that. Okay, friends, now so far we have been looping through items using a simple way, very simple design. But now we're gonna level it up and we're gonna build and design an advanced loop. In Python, there are like tools or add-ons that we can put in our loop in order to have more control, like when to stop, when to skip. And here I'm talking about the special loop statements. We have break, break, continue, pass. So let's start with the first one, the break statement. Left align, use a loop, and it must look look exactly like this output. Don't miss one character. Okay, so if you're done with this, I have for you a second challenge. You have to print the following left-aligned star pyramids. So the first line is 1 star, the second is 2, 3, and the last a simple way, very simple design. But now we're gonna leave it like when to stop, when to skip, and here I'm talking about the special loop statements. We have break, continue, pass. So let's start with the first one, the break statements. The break statement is used in order to immediately stop the loop. No matter where you are currently in the loop, you will exit. You will stop everything and go out. And once Python sees it, the loop ends right there and go to the next line of the code. So let's understand how this looks like. So now by looking back to our simple design of the for loop, you can see that Python can execute all the items inside our sequence without stopping at all from the start until the end. There will be no break, there will be nothing, unless of course your PC crashes. So everything will be executed. But now sometimes we would like to have a check. If a certain condition is met, we have to do something. So that means we have to build a condition using the if statements, and we have of course to do it inside the for loop. So let's say that if the item is equal to 2, something should happen. So now by looking back at our flowchart, that means we are building a second condition inside our loop. So again, the first condition comes from the for loop. It is something built in and we didn't specify it. But the second condition comes from the if statements that we defined inside the for loop. And of course the answer could be false or true. So now we have to tell Python what can happen if the condition is fulfilled. Of course you could like do something like print or call a function, but if you want to affect the iterations of the loop, we could use one of the 3 statements. So we could use break, continue, or pass. So now since we are talking about the break, if you go and use it, what can happen? Python gonna put a break if the condition is true, and if this happens, everything gonna stop and Python gonna go immediately to the end. But if the condition is not fulfilled, everything is like before. Python has to go and print the item. Now let's see how Python can execute it behind the scenes. So it's gonna start from the beginning and ask for the next item. So that means we are not at the end of the loop, and Python can continue. Now Python can ask the second question: is I equal to 2? Well, it's not, because 1 is not equal to 2. That's why it's go to false, and Python can print 1 in the output. Then jump back to the top and again ask the same question: are we done? Well, the iterator can answer with a value. We are not done yet, so that's why it stays inside the loop and go and ask the second question: is I equal to 2? Well, this time yes, this is true. 2 is equal to 2, and that's why Python can go to the break statements. Now what can happen once Python sees break? It's gonna destroy everything and stop everything. So there will be no more iterators, and Python jump immediately to the end and it can ignore everything else. So with that, we didn't iterate through the whole sequence. So the iterator is not done, and we have only one successful round, one iteration. But because we have fulfilled the condition and the break statements, everything stops. And in the output, you will get only 1. So as you look to this, it's like we are building an emergency exit right from the loop. If something catastrophic or emergency happens, we have to stop everything that we are doing and get out. This is exactly how the break statement works in Python. Okay, so now let's have an example where we have a list of names. So we can have something like John and Maria, and now we can have something empty. So we don't have any value inside it, and then let's say Kumar. Now you can see we have 4 values, but one of them has an issue. We have here empty. Now let's just make a normal loop in order to print the names. So we can say for name in names, and now let's go and print. So we can say f name equal to our variable, so name. Let's go and execute it. Now as you can see, we have all the 4 values and the empty one even. Now let's say that if there is something empty in my data, I don't want to continue. I want to break the loop and to stop the program. So now in order to do that, we have to make a check. So first we can say if name is equal to empty. So with that we are checking whether the name doesn't have any value. Double point, and now we hit enter and print a message. Now as you can see, we are now at the second level of the indentation. Print is inside if, and if is inside for. You have to be careful with that. So we can say empty value detected. And of course, this is not enough. We want to stop everything. So we're going to write a break. And now very important to understand, the break must be inside an if, otherwise you will break from the first iteration. So now let's go and try this out. So now in the output, you can see we processed 2 values, John, Maria, and then once we process the empty. This condition was true and we went inside it, so we printed the message empty value detected, and then the break is executed. So that means we stopped over here and we didn't process those two values, so they didn't have the chance to be printed over here. So this is exactly what can happen if you use a break inside your for loop. Now let's go to the next one, the continue statements. We use it in order to skip one loop cycle. So that means once Python sees the continue, it's gonna stop right there. But instead of ending the whole thing, the whole loop, what's gonna happen, it's just gonna jump back to the top and start at the next round. So that means it is not that catastrophic like the break where it's gonna stop everything. We are just skipping the current round and go to the next one. So let's have a simple example to understand it. Okay, so now in our code, after the condition, this time instead of using break, we will use continue. So now what's gonna happen behind the scenes is that if the condition is true of the if statements, we will have continue instead of break. But here comes the important points. After continue, we will not go to the end. We will just go jump back to the top. So we're gonna have an arrow from continue back to the start of the loop. Of course, with that, we are not saying we are going to the beginning of the iterator. So we are not resetting anything. It is just simply we are skipping the current round. So let's try this out and see what can happen if you do that. Now Python starts from the top and asks the iterator for the next item. It's gonna be the first one, so the value number 1, and then go and ask the second condition is 1 equal to 2. Well, it is false, so that's why Python gonna go to the right side and execute the loop as normal. So in the output you will get 1, and then jump back to the top to repeat and ask the same question, what is the next item? The iterator answer with 2, and then to the second question, is 2 equal to 2? This time yes, we have fulfilled the condition, and Python goes to the left side and execute continue. Continue means skip the current one and just go to the top and go to the next round. So with that we didn't do the normal iteration, so Python will not execute the print and you will not see the value 2 in the output. So we skipped the 2 because it is fulfilling the condition, and Python has to start again from the top and ask for the next item. It's gonna be 3, and then ask the second question, is 3 equal to 2? Well, it is false, and then go to the right side to the normal loop. It's gonna print the value 3 and then go to the top and ask for the next item. Well, we are at the end. The iterator asks Python to stop. So with that answer gonna be true and jump to the end of the loop. So as you can see now in the output we have 1 and 3, but we skipped one round. So it's not like the break where we stopped the whole iteration and we stopped everything and went to the end. We just skipped one single iteration because it was fulfilling the condition. This is exactly what continue means. Okay, so now back to our example where we have the 4 names and one of them is empty. It was too much, that once we found the empty over here, we stopped the whole loop. Because I would like to process as well Kumar over here. So what we can do, instead of having a break, we can say, you know what, just continue, I'll continue, and with that we will skip only this one bad value, but we'll continue the loop. So let's try this out and execute. As you can see in the output we have now name is equal to Kumar. So we processed this value and we still see our message empty value detected, and this comes from here. So that means yes, we found the bad data, but we skipped it. We didn't process it inside the branch, and with that we guarantee we are processing only the good data. And in this scenario I'm going to say continue here is more suitable than break, because if I'm using here break it is like an overreacting. I would like to process all other values. It is only bad value inside my data and I would like to process all others, and since this is not really critical I could go with the continue instead of break. Okay friends, now we come to little break, and I would like to give you a little tip. If you want to master something, like let's say mastering the functions or the data structure, I really recommend you to try to teach it. So try to explain it to a friend, to maybe a colleague at your work, because once you start teaching something you can understand the gaps in your knowledge and you start filling those gaps by maybe researching or watching one of my videos. So if you want to master something, teach it. Now that's it. Let's go back to the course. So that's all for the continue statements. Now let's go to the third one. We have the pass statements. Pass is just like placeholder where nothing happens. So this sounds a little bit strange, but all what we are saying here that I will put here code later, but for now just keep going, don't bother. What the pass statement means, for now, do nothing. So let's understand what exactly this means. Alright, now let's go and put pass inside the if statements. So that means instead of continue, we can have pass, and this can be executed if the condition is true. Now of course what is very important is where the arrow gonna go after the pass. Well, this time it will not go to the end, it will not go to the start of the loop. Well actually it's gonna go to our block of code. So it's gonna go back to the normal way of our loop. Now if you look at this, do you see something strange? Well, it doesn't matter if the answer is false and true, both of them are leading back to our block of code, right? So that means we are not stopping anything like the break, we are not skipping anything like the continue, everything gonna stay as it is. So the big question is why we need it. Well, we don't use pass very often in our coding, but we use it as a placeholder as we are planning the next steps. So for now in my code, I am sure that I have to check for this situation where I is equal to 2, but I still don't know what I'm gonna do if the condition is true. So it's like I'm planning something inside my code, I don't want to forget about it, and I'm building something temporary. And the final solution should not of course include pass. Now let's have a quick example to see how this can work. For the first value 1, well, is 1 equal to 2? The answer is false. Python can go and execute the print normally, and we will see 1 in the output, and then go back to the top and ask for the next item. You will get 2. Well, is 2 is equal to 2? This time we'll go to the left side and execute the pass, and nothing gonna happen. Python has to go back to the print and print in the output 2. So you see, we are not skipping, we are not ending anything. Then go back to the top and ask for the third item. You will get 3 in the output like usual, and the next one, the iterator will give you no value and ask for stop. That's why Python gonna end and go outside. So as you can see, it's like you are iterating without having the condition. You iterated through all the values 1, 2, 3. So again, pass means just keep doing what you are doing, keep doing the iterations, and maybe later we can add something in this place. So it is like placeholder. Okay, so now back to our example where you have the 4 names and one of them is empty. The thing is, this is yes an empty value, but I don't know yet what to do with it. I could go and replace it with dummy values like unavailable, unknown, maybe some flags, but still I don't know what to do with this. And on the other hand, I don't want to skip it. I don't want now to break the whole program or skip this step. I would like to decide about this later. So what we can do, we can go over here and say, you know what, we're gonna make a pass, and then I'm gonna go and write a note for myself so that I don't forget about it. So I'm gonna say to do handle empty value. And to be honest, I don't want to print anything in the output because we don't want to see this yet. So it is just something for me that I would like to plan for the future, but at least I know about this scenario. I know there is like an issue like this, and I have already like a condition for it to check it, but I don't know yet the action. So now, if you go and execute it, you can see we're gonna go and process all the names that we have in our list. So we are not skipping anything. Maybe after a week, I meet my team, and then we discuss about this issue. I told them, yeah, we have like some empty values in our data, and I would like to know how to handle it, and then we agreed all to have dummy value like unknown. So now I come back to my code and say, you know what, let's go and do it like this. Name is equal to name and replace. And instead of empty, we're gonna have unknown. So it is like this, and I can go and remove now the pass. We don't need it. I know the action and execute it. You can see now in the output, I'm getting the unknown. So we didn't skip, we didn't stop anything. We just prepare it for the next steps. And this is exactly how we use this statement pass in our code. So let's have a real code. So let's have real examples on how to use continue and break. So the first task, it says loop through a list of days and print only the working days, skipping the weekends. So now let's go and create a list of days. So for example, let's have a month. Monday, Sunday, Wednesday, and let's have it Tuesday, just randomly some days. So now we want to print in the output only the working days. So we don't want to see any weekends. And for that, we can go and create a for loop. So we can say for day, and days, and then double points. And now we're gonna go and print the work day, double points, and then our variable day. That's it. Let's go and execute. Now in the output, you can see we are printing everything, even the weekends, which is not really what we want. So we have to check whether the day over here is a weekend. Now for that, we have to go and create an if statement, and we can say if day in, and then we're going to have our two values, Saturday and Sunday, like this. Now, if this is a scenario, what can happen? Should we break or should we continue? Well, as the task says, we have to skip the weekend. We don't have to stop everything, yeah? So it's not that catastrophic. That's why we're gonna go with the continue. We want to skip those days, otherwise, go and print the day. So let's try this out and execute. You can see we have Monday, Wednesday, and Tuesday, but the Sunday is not in the output, and that's because it is fulfilling our condition here. So as you can see, it's very simple. Why I decided for the continue, because I just want to skip, I don't want to stop. So now one thing quickly about the styling, as you can see again, I'm always using the same name. So day in days, and one more thing, try to not put a list in conditions or maybe in the for loops. So as you can see for the days, I always define a variable outside, and for this as well here, I'm gonna go and take it out and make a variable for it. So we can say weekends, and we're gonna put it outside, and then over here we can say weekends. So now as you can see, it is now nicer and shorter and easy to understand. For day in days, if day in weekends, so it is easy to understand, and you can here extend it outside easily than extending stuff inside the for or the condition. Then things can be easy to write and easy to read. So with that, we have solved the task. Okay, so now let's have the following task, and it says, scan through a list of email addresses and prevent unsafe data from entering your system. So now, as usual, we're going to go and create some sample data. So emails like for your system. So now, of email addresses and prevent unsafe data from entering your system. So now, as usual, we're going to go and create some sample data. So emails like, for example, data@gmail.com, and another one are at outlook.de. And then we can have something strange like drop table users. And semicolon, and then we're gonna have something like maria@gmail.com. So now let's say that I would like to process my data, and I'm gonna say for email in emails, and so we can print processing email, and then double points and our variable. Like this. So now let's go and execute it. So now in the output you can see we have processed all the emails, but actually we are not doing the job. The task is to check whether everything is safe. And my friend, this is not safe at all. We have here an SQL injection. SQL injections, it's one of the most famous hacker attacks on your applications that could happen if you have any field where the user is entering data. So maybe in the registration form or in the sign in, you have a field to enter the emails, and with that, the hacker is going to use it in order to add an SQL injection to destroy your database or maybe to read important informations. And actually it is one of the easiest way in order to hack your system. That's why most of the systems must protect their data and their applications from those SQL injections. Now we can go and check whether the email includes a semicolon. Semicolon is indicator that there is an SQL statement, there is a command. So we can go and check for that for say if we we have a semicolon in email. So what can happen? We can print and we can say something like this, SQL injection, and hacker attack. So with that, we get some panic. Let's go and execute it now. Now you can see in the output we are getting the message right, but still we are processing it, which is really bad. We have to add here a control flow statement. So again, continue or break. Well, I would say I will not trust the data at all that I'm getting from this source. That's why I'm going to stop everything and I'm going to go and use a break in order to protect my system. So I will not trust the data at all that I'm getting from this source. Well, I would say here a control flow statement. So again, now you can see in the output we are getting the message right, but still we are processing it, which is really bad. We have to add here a control flow statement. So again, continue or break. Well, I would say I will not trust the data at all that I'm getting from this source. That's why I'm going to stop everything and I'm going to go and use a break in order to protect my system. So with that, you can see we are processing only the first two emails and everything else can be stopped. You can see in this example, we have high critical risk in our system and we use break in this scenario. Now let's have a quick recap and compare them side by side. The first statement is the break where we add a condition, and if this condition is fulfilled, we execute the break and we exit the loop. So you are building like critical risk in our system, and we use break.